Hello, in this short video I'd like to give you an introduction to the model defeaturing capabilities in MSC Apex. Apex can read in CAD geometry from most of the native CAD vendors, as well as neutral formats such as STEP, IGES and Parasolid. Typically when you read in CAD geometry to produce a finite element model, you find a number of features that you don't actually want to include. Things like very small holes, very small fillet radii, potentially even irregular shaped notches in the part. Taking these out one by one manually is a very laborious process, but with the defeaturing tools in MSC Apex, semi-automatic defeaturing tools, I can automatically detect and highlight the features I want to get rid of. So start with 3D holes, which is picking up on any concave cylindrical surface in the model. I'm just going to go and edit my range here to 5 and 10 millimeters so that I can see it highlights my holes I want to keep here, which are 8mm, so fall in the cyan region, and then in blue it highlights all of the smaller holes that I don't want. By selecting that on the color bar and middle mouse clicking, they're gone. I move on to 3D fillets, and again it's picking up on cylindrical surfaces, but it's found some very large ones which distorts the range, so I go in here and I change that to 1.5, change that to 5.5, and then I can go and insert some at about 2.5, 3.5, 4.5mm, and have a nice colour coding of the size of all my fillet radii. I'll start by taking out the 1mm ones at the bottom there, and take out the 2mm ones at the rib junctions, and lastly I'm going to take out the ones that join the big cross rib to the outer wall. So now I've stripped out all of my fillets and holes that I don't want in the model, and the last things I want to remove are these regular notches. Apex doesn't have a tool for taking those out automatically from the solid body, but it can from a mid-surface. So I go into the mid-surface tool here and I pick the part, middle mouse button. Now Apex goes through the model and looks for opposing surface faces and pairs them up and color codes them so that I can look through the model and see whether it's picked up the appropriate matching faces, which it appears to have done so. I can then go to extract those as a mid-surface. So what you can see here is it's made the solid body transparent and left me just with the surfaces, so I can go in and I can turn off the visibility of the solid body, so I'm just looking at the surfaces there. You can see, I think, that it's not automatically trimmed them together, so I can go for the Extend Surfaces tool, just pick them all, middle mouse button, and it automatically extends and trims the surfaces to match everything up. Now I can go back into the Defeature tool, just zoom in on one of those L faces, pick up that feature here, then I'll go in and select the edges that defines the pattern I want to eliminate. Now it's worth noting that they don't all have to be identical. You can set a tolerance on length and angle, so they could be topologically similar but of different sizes. So when I've picked the edges that I want to get rid of, the edges that define the pattern, I hit the middle mouse button. It's now asking me for the faces that I want to remove them from, so I pick that one and middle mouse, and it says are there any that I'd actually like to keep, but there aren't, so I middle mouse button again, and there we have, all of those features have been removed. I now have a complete midplane on this part, and I can go into the mesher, and I can put a 3mm quad mesh on there, very quickly like that, and then if I wish to apply thicknesses to it, I can go into the auto thicknessing tool, choose a mesh, and then choose the solid, middle mouse, and Apex will go through for each surface in the part and look normally to detect the faces that define its thickness and automatically assign a thickness to all those members. Now I can go forward within Apex using the internal solver to perform a finite element analysis on this, or I can export this mesh as a Nastran bulk data format, which can be read into pretty much any other FE package on the market, whether it's a Nastran based one or indeed any other. Thank you very much.